In question 4, the problem statement says, find the least number which must be subtracted from each of the following numbers so as to get a perfect square. So we have these 5 numbers which are not perfect squares. For each number, we have to find the smallest number that we can subtract from the number to get a perfect square. And then we also have to find the square root of the perfect square so obtained. So what we will do in each case is that we will apply the division method of finding the square root, and we will obtain a non-zero remainder because each number is not a perfect square. That non-zero remainder is the number that we can subtract from the original number to get a perfect square. So this is what we are going to do. So let's start with the first part. In the first part, the number that we have is 402. Now let's apply the division method to this number. So we put a bar over 02 and then we put a bar over 4, and now we can apply the division method to find the square root. So in the first step, we have to find the largest possible digit whose square is less than or equal to 4, and that digit is 2 because 2 square is exactly equal to 4. So the divisor in the first step will be 2, and this will also be the first digit in the quotient. And 2 into 2 is equal to 4. Now we subtract 4 and 4 gives us 0, and then we take these two digits 0, 2 and we bring them down, and that gives us 0, 0, 2. So the dividend for the second step is 0, 0, 2, which is simply numerically equal to 2. And what about the divisor? What will be the divisor for the second step? Well, the divisor, to get the divisor, we take this digit 2 and we double it, and that gives us 4. And now we have to find the largest possible digit, which will go here to the right of 4 and also here as the second digit in the quotient, such that the product of this number here and this digit here is less than or equal to the dividend, which is 2. And clearly that largest possible digit can only be equal to 0, because 40 into 0 will be equal to 0. And we can't take a digit larger than 0 because then the product will become greater than 2. And now if we divide, if we subtract, we obtain a remainder of 2, and no more digits are left in the original number. So the division process can stop at this point. So we have obtained a remainder of 2 and we have obtained a quotient of 20. What does this mean? This means that the number 402 is not a perfect square because we obtained a remainder of 2. But if we take away this remainder of 2 from the original number, we will obtain a perfect square. And what will be the square root of that perfect square? It will simply be equal to this quotient that we have obtained, which is equal to 20. And you can verify this from the original number 402. If you subtract 2, you get 400, which is a perfect square because the square root of 400 is equal to 20. So the answer to the first part is the least number that you can subtract is 2, and the square root of the number so obtained will be 20. This is the answer for part 1. Now coming to part 2, the number in part 2 is 1989. So let's apply the division method to this number. So we put a bar over 89 and then we put a bar over 19, and now we can apply the division method. So for the first step, we have to find the largest possible digit whose square is less than or equal to this number under the first bar on the left, which is 19. And that digit is equal to 4 because 4 square is equal to 16, which is less than 19. But if you take the next digit 5, 5 square is equal to 25, which becomes greater than 19. So the divisor in the first step will be 4, and this will also be the first digit in the quotient. And 4 into 4 is equal to 16. Now we subtract. 19 minus 16 gives us 3, and then we take these digits 89 and bring them down, and that gives us the dividend for the second step, 389. Now to calculate the divisor for the second step, we take this divisor in the first step 4, we double it, that gives us 8, and now we have to find the largest possible digit that will go here to the right of 8, and that will go here as the second digit in the quotient, such that the product of this number here and this digit here is less than or equal to 389, and that largest digit is 4, because 84 into 4 will be equal to 336. But if you take the next digit 5, then you will find that 85 into 5 will become greater than 389. So you can't take 5, you will have to take 4. Now if you subtract 389 minus 336 gives you 5 and 3. So it gives you 53. And now no more digits are left in the original number. So the division process stops at this point, and you have obtained a quotient of 44 and a remainder of 53. So clearly the number 1989 is not a perfect square, because we have obtained this remainder, non-zero remainder of 53. But if we take away this number 53 from 1989, we will get a perfect square, and the square root of that perfect square will be 44. So the answer for part 2 is that the smallest number you can take away is 53 to get a perfect square, and the square root of the number so obtained will be 44. And if you want, you can verify this. 1989 minus 53, this will be equal to 1936, and this is the perfect square of 44. Okay, so that completes part 2. Now coming to part 3, the number in part 3 is 3250. So let's apply the division method to this number. So we put a bar over 50 and over 32, and now we can apply the division method to calculate the square root. Okay, in the first step we have to find the largest possible digit whose square is less than or equal to 32, and that digit is 5, because 5 square is equal to 25, which is less than 32. But if you take the next digit 6, then 6 square is 36, which becomes greater than 32. So the first in the divisor in the first step will be equal to 5, and it will also become the first digit in the quotient, and 5 into 5 is equal to 25. Now if you subtract 32 minus 25 is equal to 7, and then you take these digits 50 and bring them down, and you get 750 as your dividend for the second step. And the divisor for the second step will be, how will you calculate that? Well, you will have to take this divisor 5 from the first step and double it. That gives you 10. And now you have to find the largest possible digit that will go here and that will also go here, such that the product of this number and this digit here is less than or equal to 750. And that largest possible digit is 7, because 107 into 7 is equal to 749. So just a little less than 750. But if you had taken the next digit 8, you will overshoot 750. So the digit you have to take is 7. Okay, and now if you subtract, you get a remainder of 1. And because no more digits are left in the original number, the division stops at this stage, and you obtain a quotient of 57 and a remainder of 1. And we see that the reason 3250 is not a perfect square is because we are getting this remainder of 1. So if we take away this remainder of 1, we will get a perfect square, and the square root of that perfect square will be 57. And you can verify this. 3250, if you subtract 1 from this number, you will get 3249, and this number will be exactly the square of 57. So the answer for part 3 is that the smallest number you can take away is 1, and the square root of the resulting number will be 57. So that completes part 3. Now in question 5 of this exercise, we have to find the least number which must be added to each of the following numbers so as to get a perfect square. So each of these 5 numbers that you see here, each of these is not a perfect square, and we have to find the smallest number we can add to each number so that we get a perfect square. And then we also have to find the square root of the perfect square so obtained in each case. So here's what we will do in each case. We will find those two consecutive perfect squares between which the given number lies. For example, let's take the number 30. Let's take the number 30. The largest perfect square smaller than 30 is 5 square, because 5 square is 25, which is less than 30. And the smallest perfect square larger than 30 is 6 square, because 6 square is 36, which is greater than 30. So 30 lies between the consecutive perfect squares 5 square and 6 square. And this helps you easily find the smallest number you can add to 30 to turn it into a perfect square. Just find the difference between 30 and the perfect square that comes right after 30. And this difference between 30 and 6 square is 6, because 6 square is 36. So if you add to the number 30, if you add 6, you get 36, which is a perfect square. So this is the exact strategy we will apply to each of the given numbers, and we will use the division method for this purpose. So follow me carefully as I show you how to solve each part. In part 1, we have the number 525. So let's apply the division method of finding square roots to this number. For that, we put bars over pairs of digits starting from the right. So we put a bar over 25 and then we put a bar over 5. And now we can apply the division method. So in the first step, we have to find the largest possible digit whose square is less than or equal to this number 5 under the first bar. And that largest possible digit is 2, because 2 square is equal to 4, which is less than 5. But the next digit 3 has a square of 9, which is greater than 5. So the first divisor will be 2, and the first digit of the quotient will also be 2, and 2 into 2 is equal to 4. Now if we subtract, we get 5 minus 4 as 1, and if we bring down these two digits, 2 and 5, we get the dividend 125 as the dividend of the next step. For the divisor of the next step, we take this divisor 2 and double it, and that gives us 4. And now we have to find the largest possible digit that will go here and also go here as the second digit in the quotient, such that the product of this number and this digit here will be less than or equal to 125. And that largest possible digit is 2, because 42 into 2 is 84. And you can check that if you had taken the next larger digit 3, 43 into 3 will become greater than 125. So you have to take the digit 2. Now if you subtract, you get the remainder 41, and now there are no more digits left in the original number, so the division process stops at this point. So we have obtained a quotient of 22 and a remainder of 41. So this means that the largest number whose square is less than 525 is this number, this quotient 22. So the largest number whose square is less than 525 is 22, and hence the smallest number whose square is greater than 525 is 23. In other words, the number 525, this number, lies between the square of 22 and the square of 23. So 525 lies between these two consecutive perfect squares, and hence the smallest number we can add to 525 to get a perfect square is the difference between 23 square and the number 525. So just calculate the difference between these two numbers. So 23 square is equal to 529. So the difference between 23 square and 525 is equal to 4. Okay, so we can add 4 to the number 525. So the number 525, if we add 4, we get the next immediate perfect square, which is 23 square, and the square root of that will be 23. So the answer to the first part is that we can add 4. The smallest number we can add is 4 to get a perfect square, and the square root of that number will be 23. So that completes part 1. Now let's do part 2. The number in part 2 is 1750, and once again we will apply the division method of finding square roots to this number. So we put bars over pairs of digits, we put a bar over 50 and we put a bar over 17, and now we are ready to apply the division method. So in the first step, we have to find the largest possible digit whose square is less than or equal to this number under the first bar, which is 17. And that largest possible digit is 4, because 4 square is equal to 16, which is less than 17. But if you take the next digit 5, then 5 square is equal to 25, which is greater than 17. So we take the first divisor as 4 and also as the first digit of the quotient, and 4 into 4 is equal to 16. Now we subtract. 17 minus 16 is 1, and we bring down these two digits 50, and that gives us the dividend for the next step as 150. To get the divisor for the next step, we take this digit here, we take this divisor here 4 and double it, so it becomes 8. And now we have to find the largest possible digit that we can put here and that we can put as the second digit in the quotient, such that the product of this number here and this digit here is less than or equal to 150. And that digit we can see can only be 1, and 81 into 1, because if you take 2, then 82 into 2 will exceed 150. So we have to take 1. So 81 into 1 is 81, and if we subtract now, we get a remainder of 69. And now because there are no more digits left in the original number, the division process stops at this point. So we have obtained a quotient of 41 and a remainder of 69. So this means that the largest number whose square is less than 1750, the largest such number is 41. Okay, and this means that the smallest number whose square will be greater than 1750 will be 42. In other words, the number 1750 will lie between the consecutive perfect squares 41 square and 42 square. And hence, to find the smallest number you can add to 1750 to get a perfect square, just take the difference of this number and the next immediate perfect square, which is 42 square. So 42 square is equal to 1764, and this means that 42 square minus the given number 1750, this is equal to 14. So if you add 14 to 1750, you get the next perfect square. So let's write this. 1750 plus 14 will be equal to 42 square. So the answer for part 2 is that the smallest number you can add is 14. So we put 14 here, and the square root of the resulting number so obtained will be 42. So 42 is the second part of the answer. So this completes part 2. Now coming to part 3, the number in part 3 is 252. So once again we will apply the division method to this number. For that we put bars over pairs of digits. So we put a bar over 5, 2, and then we put a bar over 2, and now we can apply the division method. In the first step, we have to find the largest possible digit whose square is less than or equal to 2, and that digit is 1, because 1 square is 1, which is less than 2. But if you take the next digit 2, then 2 square is 4, which is greater than 2. So the first divisor will be 1, and the first digit of the quotient will also be 1, and 1 into 1 is equal to 1. Now we subtract. So 2 minus 1 is 1, and then we bring down these digits 5, 2, we bring them down, and that gives us 152 as the second dividend for the second step. Now to get the divisor for the second step, we take this 1, we double it, and that's 2. And now we have to find the largest digit which will go here and also go here as the second digit in the quotient, such that the product of this number here and this digit here is less than or equal to 152. So that digit will be equal to 5, because 25 into 5 is 125. But if you had taken the next larger digit 6, then you can see that 26 into 6 will actually exceed 152. So we have to take 5, and 25 into 5 is 125. And now if we subtract, 152 minus 125 is 27. Okay, and now because there are no more digits left in the quotient in the original number, the division process stops at this point, and we obtain a quotient of 15 and a remainder of 27. This means that the largest number whose square is less than 252 is this number 15, and hence the smallest number whose square will exceed 252 will be 16. So the number 252 will lie between the consecutive perfect squares 15 square and 16 square. Okay, and hence to find the smallest number you can add to 252 to get a perfect square. Just take the difference of 252 and the next immediate perfect square, which is 16 square. So 16 square is equal to 256, and hence 16 square minus 252 will be equal to 4. So if you add 4 to 252, you get the next perfect square, which is 16 square, and the square root of that will of course be 16. So the answer for part 3 is that the smallest number you can add is 4 to get a perfect square, and the square root will be 16. So that completes part 3. Now coming to question 6 of this exercise says, find the length of the side of a square whose area is 441 meters square. So here's a figure that I've drawn for this question. We have this square whose area is given as 441 meters square, and we have to find the side of the square. So let's assume that the side of the square, each of the 4 sides of the square measures x meters. Okay, so each of the sides of the square measures x meters, and this means that the area you can now express in terms of x. How can you do that? So the area will be x into x. So the area will be x square meter square, and this means that because the area is equal to 441 meters square, this is already given to us. This means that x square will be equal to 441, or x will be equal to the square root of 441. So all we need to do in this case is simply find the square root of 441. So let's do that by the method of division, by the division method of finding square roots. So we write 441 and we put bars over pairs of digits. So we put a bar over 41 and then we put a bar over 4, and now we can apply the division method. So in the first step, we have to find the largest possible digit whose square is less than or equal to the number under the first bar, which is 4, and that digit is 2. So we take 2 as the first divisor and 2 as the first digit in the quotient, and 2 into 2 is equal to 4. Now we subtract, so 4 minus 4 is 0, and we bring down these digits 41 to get the dividend for the next step, which is 41. And to find the divisor for the next step, we take this number 2, divisor 2, and we double it. That gives us 4. And now we have to find the largest possible digit that can go here to the right of 4 and as the second digit in the quotient, such that the product of this number and this digit here is less than or equal to 41. And that digit is clearly 1. So 41 into 1 is equal to 41. And now when we subtract, we obtain the remainder 0, and no more digits are left in the original number 441. So the quotient that we obtain, which is 21, this is basically the square root of 441. So the square root of 441 is 21, and hence the side of each square is equal to 21 meters. So this is the answer for question number 6. The problem statement in question 7 says, in a right triangle ABC, angle B is equal to 90 degrees. So the angle at vertex B is 90 degrees. The first part says, if AB is 6 centimeters and BC is 8 centimeters, find AC. And the second part says, if AC is 13 centimeters and BC is 5 centimeters, find AB. So to solve each of these parts, we will make use of the Pythagoras theorem, which can be applied to any right angled triangle. So for the first part, here's this figure that I have drawn for the first part. Observe it carefully. So triangle ABC is right angled at B, and AB is equal to 6 centimeter and BC is equal to 8 centimeter. So we will make use of the Pythagoras theorem, which says that the hypotenuse AC, the square of the hypotenuse will be the sum of the squares of the other two sides. So AC square will be equal to AB square plus BC square. and AB square is, AB is 6, so AB square will be 36 centimeters square, and BC square is, BC is 8, so BC square will be 8 square or 64 centimeters square. So 36 plus 64 is equal to 100. So AC square will be equal to 100 centimeter square. And this means that if we take the square roots on both sides, so AC will be equal to root of 100 centimeters. And now to calculate root of 100, we can either use prime factorization or the division method, but because the value inside the square root is very simple, we know that the square root of 100 is simply 10. We can write it directly as well. So the length of AC will be equal to 10 centimeters. So this is the answer for the first part. The length of AC is equal to 10 centimeters. Similarly, now let's do part. In question 8, the problem statement says a gardener has 1000 plants. He wants to plant these in such a way that the number of rows and the number of columns remains same. Find the minimum number of plants he needs more for this. How many additional plants does he need? So what this problem basically means is that he wants to plant all his plants in a square formation, so that the number of rows and the number of columns remains the same, which means that he wants to plant in a square formation, and which means that the total number of plants he has must be a perfect square for him to be able to do that. But the number he has right now, 1000, this is not a perfect square. So we have to find out how many additional plants should we add to this number 1000, so that the resulting number becomes a perfect square, because then he can plant them in a square formation. So that's what we have to do. We have to find the smallest number that we can add to 1000 so that it becomes a perfect square. To do that, let's apply the division method of finding square roots to the number 1000, and let's put bars over pairs of digits like this, and let's start applying the division method. Okay, now for the first step, we need to find the largest possible digit whose square is less than or equal to 10, and that digit is 3, because 3 square is equal to 9, which is less than 10. But if you take the next digit, that's 4, and 4 square is 16, which exceeds 10. So we will take 3 as the first divisor and also as the first digit in the quotient, and 3 into 3 is equal to 9. Now 10 minus 9 is equal to 1, and we take these digits 0 and 0 and bring them down, and that gives us the dividend for the second step as 100. To find the divisor in the second step, we take this first divisor and double it, and that gives us 6. And now we have to find the largest digit that will go here to the right of 6, and that will also go as the second digit in the quotient, such that the product of this number, the product of this whole second divisor and this digit here, is less than 100, less than or equal to 100. And that largest possible digit is 1. So 61 into 1 is equal to 61. And you can see that if you had taken the digit 2, then 62 into 2, it will exceed 100. So we have to go with 1. Okay, now we subtract once again, and 100 minus 61 is equal to 39. And now there are no more digits left in the original number 1000. So at this point, the division process terminates, it stops, and we get a quotient of 31 and we get a remainder of 39. And we can see that because we have this non-zero remainder, the number 1000 is not a perfect square. But what we also find is that this quotient 31, this number, is the largest possible number whose square is less than 1000. So 31 is the largest possible number whose square is less than 1000, and this means that the next number 32 is the smallest possible number whose square is greater than 1000. So 1000, the number 1000, basically lies between the consecutive perfect squares 31 square and 32 square, and hence what we can do is that the minimum number that we can add to 1000 to turn it into a perfect square is the difference of 1000 from this next immediate perfect square, which is 32 square. So 32 square is equal to 1024. So if we take the difference of this square, 32 square, from the given number 1000, we get 24. So if we add the number 24 to the given number 1000, we turn it into a perfect square, and that perfect square is 32 square. So basically what the gardener should do is that he should take 24 more plants. He should take 24 more plants and add them to the 1000 plants that he already has, and then he will get a total of 1024 plants. And because 1024 is a perfect square, it is a perfect square of 32, he can now plant all these plants in a square formation in which the number of rows as well as the number of columns is 32. Okay, so the answer for question 8 is the minimum number of plants he needs more for this is 24. This is the answer for question number 8. Problem statement says there are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to the number of columns. How many children would be left out in this arrangement? So let me explain this question a little bit more. Basically what this question says is that there are a total of 500 children in the school, and for a drill, what is done is the children are made to stand in a square formation because the number of rows is equal to the number of columns. So as many children as possible are made to stand in a square formation, but some children will be left out. And why is that? That is because 500 is not a perfect square. So if you try to arrange 500 children into a perfect square formation, some of them will definitely be left out because 500 is not a perfect square. So we have to find out how many children will be left out. So basically what we have to do is we have to find the largest possible square formation that we can make out of 500 children, and the gap between that number and 500 will be the number of children that will be left out. So for this purpose, let's apply the division method to the number 500, the division method of finding square roots. So we put bars over pairs of digits over 0, 0 and then over 5, and now we can apply the division method. So in the first step, we will have to take the largest possible digit whose square is less than or equal to this number 5 under the first bar, and that largest possible digit is 2 because 2 square is equal to 4, which is less than 5. But if you take the next digit 3, then 3 square is equal to 9, which exceeds 5. So we will take the digit 2 as the first divisor and also as the first digit in the quotient. So 2 into 2 is equal to 4, and now we subtract. So 5 minus 4 is equal to 1, and we take these two digits 0, 0 and bring them down, and that gives us 100 as the dividend for the second step. And what about the divisor for the second step? For that, we take this first divisor and double it, and that gives us 4. And now we have to find the largest possible digit that will go here to the right of 4 and as the second digit in the quotient, such that the product of this number and this second digit is less than or equal to 100. So that largest possible digit is 2, and 42 into 2 will become 84. So 84 comes here, and now we subtract again, and this gives us the remainder as 16. And now because there are no more digits left in the original number 500, the division process terminates at this point. Okay, and we obtain a quotient of 22 and a remainder of 16. So what this basically means is that 22 is the largest possible number whose square is less than 500. In fact, 22 square is equal to 484, which is quite close to 500. And the remainder is 16. The remainder is 16. The difference between 500 and 484 is 16. And this basically means that when you try to arrange 500 children into a square formation, you will end up arranging 484 of them into a square formation where each row and each column contains 22 students, and there will be these many students left. So the remainder, which is 16, will be the number of students which will be left out of the arrangement. So the answer for question number 9 is that 16 students will be left out. And this completes question number 9.
Thank you for watching our channel. If video உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம